this is Phil Parker, and what I'd like to do in this short video is just describe to you my intuition between unsupervised machine learning and supervised machine learning. Now, stepping pretty far back, unsupervised machine learning, or what my generation used to call data grubbing, is just visualizing or describing data in an efficient way. Data is often extremely complex, and all we want to do is just boil it down to something that we can interpret very easily. But we also want to make it useful. So often there's a notion of visualization, in particular maps and groupings of data. These will lead to techniques we'll talk about later called factor analysis and cluster analysis, for example, versus supervised machine learning. And what's that all about is it's not describing the data per se, but rather I'm actually trying to predict certain things. I describe in a model what my y variable is. What do I want to predict? And then I come up with some independent variables. Those independent variables will explain my y variables. So in essence, supervised machine learning, it's about predicting things. It's about explaining why data changes. Whereas in unsupervised, it's just describing data. So let me quickly now give you a little bit of my intuition and how I describe the difference between the two. Let's start with a simple example of describing the ingredients in a salad. Now let's assume we could put a variety of things in a salad. How could we characterize those ingredients? Now, if we had a lot of time, we could actually use nutritional information. We could use a variety of types of information. I'm just going to say two types. One is the color of the ingredient, and the other is how sweet is the ingredient. Those are just two variables. They don't predict each other. Color does not predict sweetness, and sweetness does not predict color. Now, how do I want to represent those two dimensions and the different ingredients that go into a salad? Well, I'm going to plot it with a map. So I'm just going to draw a 2x2 map here, and we'll just call one variable x1 up here at the top, and let's make sure that's sweetness. All right, so that's sweetness. Okay, how sweet is the fruit or the vegetable? And then down here on the other side, we might have the word color, right? And that's our second x variable. Two x variables, there is no y variables. Now, on color, we could use the spectrums of colors. These are typically measured in nanometers or things like that. So we'll put red over here on the far right-hand side. That represents roughly 740 nanometers. On the left-hand side, what we've got is we've got green. We've got green, and that represents in light about 525 nanometers. Very technical dimensions, right? And then on sweetness, we could just say, let's say -10 is very bitter, not very sweet, and +10 is extremely sweet. Now, question, where do the different ingredients of a salad plot within these two dimensions? So what we've done is we've boiled down all of the possible things we could think of to just two dimensions, or what some people might call two factors. Okay, so where does raspberries go? Well, they're kind of red, and a little bit bitter, a little bit tart raspberries go here. Where would red apples go? Red apples, maybe they go here. Red apples go here. Okay, and with strawberries, maybe go here as well. Strawberries. Where does, let's say, peas go? Well, peas are kind of green, but they're not really that sweet. Where would, for example, salad go? Well, that's less sweet than peas, so I'm going to put it there and put salad there. Lettuce, for example. Where am I going to put, bananas? Well, they're actually in between 525 and 7. That's yellow. That's kind of in between on this spectrum. So I'm going to put bananas here. Bananas go there. Where would I put, red bell peppers? So red bell peppers go down in this corner. Red bell peppers go here. Okay. And then where would I put, kiwis, for example? Kiwis would be kind of green. They would go up here. Maybe some green grapes would go up here. And maybe I might actually put some green apples would go here, green apples. And then there's famous durian. Durian might go down here, maybe not so sweet, okay? And we might have something like rhubarb or something like that down at the bottom here. Okay, so what we've just done is we've shown that there's a number of different fruits and vegetables on a two-dimensional plane. Basically, the complexities of all these ingredients are now plotted on a two-dimensional map. And that's often the output of a data reduction or unsupervised machine learning algorithm. Now, given those given those plots, you then could say, well, I noticed that some things are more similar to each other than to other things. For example, a red apple is more similar to a strawberry than either of those two are to, let's say, green peas. Well, if that's true, we can use an algorithm to maybe group things together. So that might be called a cluster. There might be a cluster over here and another cluster over here. So we typically do data reduction, and then based on that data reduction, unsupervised machine learning, we then decide to form clusters. Now, those clusters become managerially important if we want to, for example, say, well, I wonder where, for example, peaches might go. Well, peaches probably would go here. They do not belong to any of the existing clusters, but they might belong to a cluster called bananas, for example. So using plotting of data, creating maps, just gives us a little bit of insight into the existence and or the difference across data points. That's some intuition with respect to unsupervised machine learning. X2 color does not predict X1 sweetness, nor does sweetness predict color. They're simply two independent factors, or what a statistician might call orthogonal factors, that help me understand and describe a data set. Now, what is supervised machine learning? That's a little bit different. In supervised machine learning, we have to have some notion of a model. Y equals A plus BX, for example. So something predicts something, and we'll use machine learning tools to estimate the A and B parameters. That's why we have modeling take place after we've typically done data reduction and cluster analysis. So let's plot two dimensions here. Let's plot two dimensions. Again, both can have dimensions that look similar, but in the second case, we have a Y variable. What are we trying to predict? Let's say we're trying to predict someone's preferences. Do they actually like this product or not? Preferences. This is how happy they are. If they don't prefer something, let's put a sad face at the bottom. All right. So let's say that's on a scale of -10 to +10. Okay. So we have a scale of preferences. Do they like it or do they not like it? And then on the horizontal, let's take X1. X1, which was sweetness. So now we're going to predict the degree to which someone prefers something based on its sweetness. If we were looking at candy, or we're looking at someone who likes sweet salads, we would have a model that might predict the following, based on perhaps the literature from healthcare or some other sciences. We discovered that humans generally prefer sweet things. The less sweet it is, the more people dislike it. But eventually, if it's too sweet, they may not like it very much. It's just too sweet. So now we have a relationship whereby if something is toxic, i.e. not sweet, we discover that people definitely do not want it. If they want something that they prefer, if you want to give something to someone they prefer, rather, what you do is you actually increase the sweetness. But there's a point at which it can become too sweet. This is supervised machine learning. A variable X, sweetness, predicts preferences. Now, if someone wanted to use that model to create the optimal salad for someone, you would simply have to ask them, would you like your salad to be very sweet or not very sweet? Well, if I want it to be sweet, then I'd go to the first graph and say, well, what are the sweet fruits or vegetables? And then I would say, well, I want to have it very colorful, so I want one green, let's say some kiwis, maybe slice in some peaches for a little bit of color variation, and maybe some sliced strawberries, i.e. those three clusters are complements to each other. Within the clusters, they are substitutes for each other based on their colors. Okay, that's my intuition between supervised and unsupervised. Unsupervised, just plotting data, looking at clusters, quite interesting. Supervised is where I'm using that kind of data to forecast something else. For example, preferences or market shares or belongingness or any other variable that's important to management. There you go. That's the intuition of supervised and unsupervised machine learning. Now we're going to learn more about how to estimate models using those techniques. Bye-bye.